Welcome to The Explainer. Today, we're going to pull back the curtain on the technology that stops your favorite apps from crashing during their busiest moments. It's called Apache Kafka, and you're about to find out why it's one of the most important pieces of software running the world today.
You've been there, right? It's so frustrating. You're trying to order food during the big game, or maybe you're grabbing concert tickets the second they drop, and bam, the app just freezes. To understand why that happens, let's take a little peek behind the scenes of a typical food delivery app.
Okay, so the moment you hit that place order button, this kind of fragile chain reaction kicks off. The app's main brain has to directly call the restaurant system, that's its API, think of it as its digital front door. Once it gets an OK back, it calls the delivery service, then it calls an analytics service, and then finally a notification service to send you that confirmation text. Every single step has to happen in this perfect, rigid sequence.
Now, this kind of setup, engineers call it a tightly coupled architecture. It works just fine on a quiet Tuesday night, but it's got this massive, hidden weak spot for when things get really, really busy.
So, picture this. It's the final match. The whole country is glued to the TV, and at the exact same moment, everybody decides they want pizza. Suddenly, that system isn't just handling a few orders a minute. It's being slammed with millions, and that fragile little chain is about to be put under some serious pressure.
See, in this kind of system, each step is forced to wait for the one right before it to finish. It's like a one-lane road. The delivery service can't get called until a restaurant officially confirms the order. This is what we call synchronous, or blocking, processing. And when just one of those services gets overwhelmed and starts to slow down, well, you're heading straight for a catastrophic bottleneck.
It is a perfect digital traffic jam. If just one of those services, let's say the restaurant system, can't handle the flood of orders and it grinds to a halt, it doesn't just slow down that one little step. Nope, it stops everything. The entire system is now in total gridlock, and for you, the user, the app is completely frozen, useless.
So let's just be really clear about this. This design has two huge fatal flaws. First, it's incredibly fragile. One slow part can crash the whole thing. And second, it's super inflexible. What if your company wants to add a new feature, like a loyalty point service? You'd have to perform risky surgery on the core code, which just slows down innovation to a crawl. So, how do we fix this, right? How can we build a smarter, more resilient system that doesn't just fall apart under pressure?
Well, the big idea, the breakthrough, is to just break those direct connections. What if instead of making all those individual one-by-one calls, the main order service could just shout, "Hey, I've got a new order," into some central place and then immediately move on to the next thing?
In this new model, the application that creates the message, our order service, gets a special name. It's called the producer. Its only job is to produce a message, something like order number 123 has been placed, and just drop it into a central message buffer.
And then all those other services, the restaurant, the delivery, the analytics systems, they become consumers. They just independently listen to this central buffer. And whenever they see a new order message that they care about, they grab it and start their work whenever they're ready.
This is what we call a decoupled system, and it changes everything. The producer isn't blocked. It's not waiting for a response. It just drops off the message and moves on. And the consumers, they can process those messages at their own pace. If the restaurant service is slow for a few minutes, it doesn't stop the delivery service from seeing the order. The traffic jam is just gone.
So this really powerful idea is actually the foundation for one of the most important technologies in our modern world.
This elegant solution, this central buffer that can handle an almost unbelievable number of messages without even breaking a sweat, it has a name you've probably heard before.
It's called Apache Kafka. And while it does act like a super efficient message buffer, its real power lies in how it treats data, not as something that just gets used up and thrown away, but as a permanent record.
So here's the official definition. Kafka is an event streaming platform. And the keywords you really want to lock onto there are streaming, durable, and in order. They are the secret sauce to what makes this whole thing so incredibly powerful.
To really get the magic of Kafka, you gotta compare it to older technologies, like a traditional message queue. And trust me, this is where things get really cool.
Honestly, the best way to think about the difference is this. A traditional message queue is like postal mail. Once you open the letter and read it, it's gone. That's it. Kafka, on the other hand, is like a YouTube video. You can watch it, but the video doesn't disappear. Your friends can watch it, you can come back and rewatch it tomorrow. The data is still there. It persists. And this right here,
This is the absolute game changer. With Kafka, those messages are stored, acting as a durable, unchangeable log of events. What does that mean? It means if a consumer service crashes, it can come back online later and replay all the messages it missed. This is the big insight. Instead of data sitting still in a database, it's now a living, flowing stream that any service can tap into at any time.
So, why is this replayability and scalability so important? I mean, why does this all matter? Let's take a look at the incredible scale of Kafka's adoption across the industry.
Pretty much every major tech company you can think of relies on Kafka. Netflix uses it to process your viewing habits in real time to give you recommendations. Tesla streams massive amounts of sensor data from its cars. Credit card companies use it to detect fraud in milliseconds. And this whole thing was actually invented at LinkedIn to handle their huge data flows.
And when I say massive, the scale is it's hard to wrap your head around. At LinkedIn alone, Kafka handles 7 times trillion messages every single day. Just let that sink in for a second. Not million, not billion, trillion.
Yeah.
So with that kind of power and rock-solid reliability, it's really no surprise that today an estimated 80% of all Fortune 100 companies use Kafka to power their most critical real-time systems. So you see, Kafka does way more than just stop your food app from crashing. It really represents a revolution in how we see data itself, not as something that's locked away in a database, but as a continuous, unending stream of events that tells the story of a business in real time. By creating these data pipelines that are resilient, scalable, and that never clog, it unlocks the real-time world we